Hello students, welcome to the next physics class. This video is part 5 on motion in a plane. Students, today we are going to see an interesting topic, that is projectile motion, in which we are going to see equation of path of a projectile, time of flight, maximum height of a projectile, horizontal range of a projectile. Okay, shall we start the topic? Yes. Projectile motion: when any object is thrown from horizontal at an angle theta except 90 degree, then the path followed by the object is called trajectory. The object is called projectile and its motion is called projectile motion. You can see very well this in your animation. Okay, what I have given to you, you can see very well. Fine. So when any object is thrown from horizontal at an angle theta except 90 degree, the object is called projectile and its motion is called projectile motion. Such a projectile might be a football, cricket ball, or a baseball, whatever it may be. The motion of a projectile may be thought of as the result of two separate simultaneously occurring components of motion. One component is along horizontal direction without any acceleration, and the other along vertical direction with constant acceleration due to the force of gravity. So you can see this in your animation. So I have given you Vx and Vy. Okay, so we have two components. One component is along horizontal direction without any acceleration, and another component is along vertical direction with constant acceleration due to the force of gravity. Before going to the derivation part, we must know the assumptions. Okay, so what is the first assumption? Okay, so look at the first point, that is no frictional resistance of air. You should imagine, before going to the derivation part, you should imagine there is no resistance of air. Second point, the effect due to rotation of earth and the curvature of the earth is negligible. So what is your second assumption? The effect due to rotation of earth and the curvature of earth is negligible. Third assumption is the acceleration due to gravity is constant both in magnitude and direction at all points during the motion of projectile. So students, these are your three assumptions. So first assumption is there is no frictional resistance of air. No air resistance. Second point, the effect due to rotation of earth and the curvature of earth is negligible. Third assumption is the acceleration due to gravity is constant both in magnitude and direction at all points during the motion of projectile. Okay students, we are going to start the derivation part. So first part is equation of path of a projectile. So as I told you before, the projectile, the path followed by the projectile has two components. One component is along horizontal direction without any acceleration, and another component is along vertical direction with constant acceleration due to gravity, due to force of gravity. So we are going to see what is the motion along horizontal direction and motion along vertical direction. Students, before going to this derivation, we must see the graphical representation which I have given in the slide. So look at the graph, everybody. Let OX be a horizontal line on the ground. OY be a vertical line perpendicular to ground, and O be the origin for XY axis on a plane. So what I told, OX is the horizontal line on the ground, OY vertical line perpendicular to ground, and O is your origin. Suppose, imagine an object is projected from point O with velocity u, making an angle theta with horizontal direction OX. Okay, so what you have to imagine, you're going to throw some object from point O with velocity u. So that object is going to make an angle theta with horizontal direction OX, such that x naught, that is initial position, will be 0. X naught is equal to 0 and y naught is also equal to 0 when time is equal to 0. Okay. Now, while resolving velocity u into two components, okay, so you're going to resolve. Resolve means what? Splitting, right? So you're going to split a velocity u into two components. That is u cos theta along OX and u sin theta along OY. As the horizontal component of velocity u cos theta is constant throughout the motion, so there is a constant acceleration and hence force is in the horizontal direction if air resistance is assumed to be 0. As the vertical components of velocity u sin theta decreases continuously with height from O to H due to downward force of gravity and it becomes 0 at a point H. Look at the point H, which is in the topmost point. I've marked this point as P. Okay. At this point, the object has only horizontal component. You can see it has only ux, only horizontal component, not uy. Okay. So object has only horizontal component velocity, that is u cos theta. It attains a maximum height at AH. Okay. So this point, this point is A. So it attains a maximum height. Okay. So what is this distance? What is this height from the ground level? Is capital H. I have given here. Okay. OB is the maximum horizontal range. So look at the diagram. This is your origin O and this is your point B. So what is your OB? OB is your maximum horizontal range. It is denoted by capital R. Okay. So OB is your maximum horizontal range and AH is your maximum height. Okay. So hope you understand this diagram. Now we'll get into this derivation part. So first we are going to see motion along horizontal direction, that is along OX. The velocity of an object in horizontal direction, that is OX, is constant. As I told you, the velocity of an object in horizontal direction is constant. So the acceleration AX. Okay, so again acceleration has also two components, that is AX and AY, along X direction and along Y direction. Okay, so this AX is also 0 because the velocity is constant throughout. So therefore the position of the object at time t along horizontal direction. So what is the position equation, position time relationship? X equal to ut plus half at squared, isn't it? So x is equal to x naught. So okay, you can write this equation. You may studied about this equation in the previous video. X minus x naught. Okay, so that will represent you the position. So after replacing, you will get x equal to x naught plus u xt. So we are talking about the horizontal direction alone, along x axis alone. So u xt plus half axt squared. So as I told you, x naught equal to 0 and ux is your horizontal component, that is u cos theta, and ax is 0 because the velocity is constant throughout the horizontal direction. So acceleration will be 0 and t equal to t. So if you substitute all the values, you will get x equal to u cos theta into t. So what is the time now? Time equal to x divided by u cos theta. So this is your first equation. So what we derived? We derived what is the motion along horizontal direction. Okay, next we'll see motion along vertical direction, that is OY. Okay, along vertical direction. The vertical velocity of the object is decreasing from O to H. So as I told you in the previous graph, once it reaches the maximum height, the vertical component becomes 0. So the vertical velocity of the object is decreasing from O to H due to gravity. So acceleration AY is G. So acceleration of your vertical component is dependent on the gravity G. Therefore, position of the object at any time t along vertical direction, that is OY. So how we can write the same position time equation, but in place of x we are going to replace y. Okay, y we are going to calculate the motion along vertical direction along y axis. Am I clear? So this is your equation, students. Y equal to y naught plus uyt plus half ay t squared. So as I told you, y naught, that is initial position, is 0 and uy is u sine theta and ay is minus g. Why? Gravity towards downward direction. You are throwing some object in a projectile motion which is against the moment of gravity, against your direction of gravity. So ay equal to minus g. So substitute all the values in the given equation. You will get u equal to, y equal to u sine theta into t plus half minus g t squared. Okay. So u sine theta t minus half gt squared. So take this equation as number 2. Now you have to substitute the value of t. So what we derived in previous equation, what is your first equation? So I'll write here. Your first equation is t equal to x divided by u cos theta. So this was your first equation. Am I right? So this first equation, you're going to substitute the value of t from equation 1 in equation number 2. So what is your motion equation along y-axis? Y equal to u sine theta into t. In the value of t, you are going to substitute x divided by u cos theta minus half g t squared. So x divided by u cos theta, the whole squared. Okay, and now combine these two equations. U sine theta divided by u cos theta. Okay, fine. And sine theta by cos theta is tan theta, x tan theta minus half into g x divided by u cos theta, the whole square. Okay, and this u will get cancelled. Sine theta by cos theta is tan theta and here you have x. So combine all this. So x tan theta minus half g into x divided by u cos theta, the whole square. Okay. So what is your total vertical distance? Y equal to x tan theta minus half g divided by u squared cos squared theta into x squared. We just replaced the equation, rearrange the equation, that's all. So this equation represents the parabola and this is known as equation of trajectory of a projectile. Very important. So this equation is equation of trajectory of a projectile. Okay. So study this. One of the important question in this chapter, motion along horizontal direction, we derive what is t. Motion along vertical direction, we derive the parabola equation, that is equation of trajectory of a projectile. Okay, next part of this derivation is time of flight. So what is this term? It is defined as the total time for which projectile is in flight. That is time during the motion of projectile from O to B. It is denoted by capital T. Okay, I repeat, it is defined as the total time for which projectile is in flight. That is, time during the motion of projectile from the origin O to B. That is the final point. Okay, fine. So it is denoted by capital T. So total time of flight consists of two parts. So first part is the time taken by an object to go from point O to H. So H is the maximum point of the projectile. Okay. So the first part is the time taken by an object to go from point O to H. It is also known as time of ascent. Okay. It is denoted by small t. And the next part is the time taken by the object to go from point H to B. I'll draw here. So I hope you remember this graph. So this is your point O, origin. This was your projectile. This is your point B. Okay. And the midpoint is capital A. Okay. And this is your maximum height reached by an object. Okay. So as I told you, the total time of flight consists of two parts, isn't it? So from point O to H. From point O to H. This is your first part. So this is also known as time of ascent. And the next part is the time taken by an object to go from point H to point B. So this is your second part of the flight. Okay. So the total time is the time of flight. It is denoted by capital T. Okay. So shall we write like this? So capital T, total time, is equal to time of ascent, and this small t is time of descent. Ascent plus descent. So capital T equal to 2 times of small t. So what is small t? Capital T by 2. So this relationship we are going to substitute in the equation. So the next point is the vertical component of velocity of object becomes 0 at the highest point H. So this also we discussed in the previous slide. So what is the vertical component vertical component of velocity at the highest point H? So I have given you in the graph, it has only horizontal component, not the vertical component. So horizontal component is u cos theta. Okay. The vertical component becomes 0 at the maximum height. Am I clear? So, I'm sorry. Fine. Let us consider vertical upward motion of an object from O to H. So, what is your vertical component? Uy equal to u sin theta, and ay, acceleration in y direction, is minus g against the gravity. So, it was minus g, and small t equal to capital T divided by 2. So, where capital T is total time of flight. Okay, and divided by 2, and Vy equal to 0, because at the maximum height the final velocity becomes 0. Okay, the velocity becomes 0 at the maximum height. Now this is your first equation, isn't it? V equal to u plus at. This is your motion equation, first equation. Clear? And substitute all your values. Vy is 0, uy is u sin theta, and ay is minus g, and small t is capital T by 2. Now you can calculate what is your total time of flight, that is capital T. So capital T equal to 2u sin theta divided by g. So this is your next part of your derivation, that is time of flight. So what is time of flight? It is defined as the total time for which projectile is in flight. That is, Time during the motion of projectile from O to B. Okay. Next part of this derivation is maximum height of a projectile. Okay, so look at the derivation, look at the definition. It is defined as the maximum vertical height attained by an object about the point of projection during its flight. It is denoted by capital H. Okay, so read it again. It is defined as the maximum vertical height. Okay, so this is your, look at the graph now. This is your maximum vertical height attained by an object about the point of projection during its flight. It is denoted by capital H. Now, let us consider the vertical upward motion again of an object from O to H. We have, what is the vertical component? Uy equal to u sine theta, and ay equal to minus g. Y naught, initial position is 0. Final position is capital H. Okay. And t, small t equal to capital T by 2, where capital T is time of flight. Okay. So what we derived in the previous slide, capital T equal to 2u sine theta, 2u sine theta divided by g. Okay. Then what is t by 2? U sine theta by g. Am I clear? So divided by 2, you will get small t. Okay. And substitute these values in the position time relationship. Y equal to y naught plus uyt plus half ayt squared. So y is capital H and y naught is 0. Uy is u sine theta and t is u sine theta by g, and again ay equal to minus g and t squared. So once you substitute all your values, you will get capital H equal to u squared sine squared theta divided by 2g. I repeat, maximum height attained by the object is H, capital H is equal to u squared sine squared theta divided by 2g. Now we are going to see the last part of this derivation, that is horizontal range of a projectile. So what is horizontal range? Let me draw here. This is your graph, x-axis, y-axis. This is your origin and this is your projectile. Okay, and the maximum range is O to B. Okay, and it is denoted by capital R. And this is your height, maximum height reached by an object, capital H. Okay, right. So look at the definition now. Horizontal range of a projectile. The horizontal range of the projectile is defined as the horizontal distance covered by the projectile during its time of flight, and it is denoted by capital R. Okay, right. If the object having uniform velocity, see we are considering uniform velocity, u cos theta, okay, and the total time of flight is capital T, then the horizontal range covered by the object is capital R equal to u cos theta into T. How it came? Very simple. We know the formula, velocity equal to distance by time. Okay, so here velocity is u cos theta along horizontal direction, isn't it? So velocity will be u cos theta and time equal to capital T. We are considering the total time of flight. So capital T. And this is your distance. So what is the distance here? Horizontal range of a projectile, that is capital R. Okay, so by using this simple relationship, we are writing this equation as capital R equal to u cos theta into T. So substitute your values, substitute the value of T from the previous slide. So T equal to 2u sine theta by G, isn't it? So what you will get? Capital R equal to u squared sine 2 sine theta into cos theta. Yeah, 2 sine theta into cos theta. What is 2 sine theta cos theta? Yes, sine 2 theta. Okay, this is one of your trigonometry formula. Sine 2 theta equal to 2 sine theta cos theta. So substitute sine 2 theta here. So you will get R equal to u squared sine 2 theta divided by g. So this is your maximum horizontal range. Yes. Now look at here. The horizontal range will be maximum. See, one of the important MCQ question. So horizontal range will be maximum when sine 2 theta equal to 1. Okay. Then what is the value of theta? Theta equal to 45. Exactly. Theta equal to 45. Whenever the theta will be, so this is your theta, right? Look at the graph. This is your theta. Okay. So this, whenever the angle is 45 degree, you will get maximum range, maximum horizontal range. So RM, maximum horizontal range, suffix. Okay, look at the suffix, M will be there. Okay, so maximum horizontal range RM equal to U squared by G. Okay, so what we got? Horizontal range formula we got R equal to U squared sine 2 theta by G, and maximum horizontal range is RM equal to U squared by G. Okay, let us see a small recap of today's topic. So today we saw about projectile motion. Okay, so what is projectile motion? Projectile motion is a form of motion in which an object or a particle is thrown with some initial velocity near the Earth's surface, and it moves along a curved path under the action of gravity. So path followed by a projectile is called its trajectory. Okay, and example are a tennis ball or a baseball in a flight. Right, and we saw few assumptions before the study of projectile motion. So first assumption is there is no frictional resistance of air, and the second point is the effect due to rotation of earth and the curvature of earth is negligible, and last we considered acceleration due to gravity is constant both in magnitude and direction at all points during the motion of projectile. So these were assumptions before going ahead with the derivation part. And what is the first derivation? Motion along horizontal direction we saw. So here we derived what is the time. So small t equal to, in terms of your horizontal direction, small t equal to x divided by u cos theta. Okay, so this we derived in the first part. And in second part, that is motion along vertical direction, we derived total vertical distance, that is y equal to x tan theta minus half of g divided by u squared cos squared theta into x squared. So this equation is nothing but parabola, that is, it is known as, this equation is known as trajectory of a projectile. And third part we derived what is the total time of flight, that is capital T. So capital T equal to 2u sine theta divided by g. And next part is maximum height of the projectile, that is capital H. So what is capital H? U squared sine squared theta divided by 2g. Okay, u squared sine squared theta divided by 2g. So this we derived. And last part we derived as horizontal range of a projectile. So here horizontal range is denoted by capital R. Capital R is nothing but u squared sine 2 theta divided by g. Okay, and we derived what is the maximum horizontal range of a projectile. Okay, so when theta equal to 45 degree, we got maximum horizontal range. So it is denoted by R suffix m is nothing but u squared divided by g. Okay, so that's all students. Your projectile motion question was over. Students, practice this equation again and again. So in exam they may ask you to derive any 2 or 3 parts of this derivation, right? So I'll meet you in my next video. Thank you.